Hello, good afternoon. Thanks for being here. Today is gonna take place the last part of our conference. It is a sad day for those who love football this month. Okay, sorry for interrupt you for a second, but this month Maradona passed away, and today also probably one of the best Italian players, Paolo Rossi, died. So in this sad day, today we'll be talking about mprobe and a few other tools that we have developed through the years. The agenda is a little bit different from last time because we have decided to talk a little bit about our tools ourselves, so what Ntop is doing, and also to let other people discuss and report to the community what our tools are also doing for people that are not part of Ntop but that are using in their projects, in the daily work. I will start with mprobe. I will talk a little bit about how to use mprobe because many people are using mprobe as a way to send traffic to Ntopng, but there are many options that not everybody knows and that probably are worth to be discussed. And also to talk a little bit and introduce the argument of embedding, because these days, we are moving, we are still moving. I mean, many people already did to the cloud, or we have to monitor networks that are distributed. In such distributed networks, it is important to collect data where data happens. So where, in essence, where there is traffic, and send to the central location the report about the data. So sometimes, we have a virtual infrastructure, and sometimes you simply lack a device for doing this, so you need a device. So that's why we are going to talk about embedding. And then Carlos Talbo will be talking about Ntopng on Ubiquiti UDM systems. This is an interesting project. I hope Carlos can join. Carlos lives in Chicago, that he did. So this is another way of embedding our tools into third-party devices. Matteo, that you have already met in previous meetings, will be talking a little bit more in detail about alert and endpoints. In particular, today we'll focus on security onion, just to show you how to deliver the information that is collected through mprobe to an endpoint, because many people don't care about traffic, but they just care about alerts. So this is a way to do that, okay, using endpoints. And then Alfredo today wants to talk about ntopdisk. The idea is that even, like I said, for mprobe, to cover in detail this tool, because many people knows us because of Ntopng, because it's probably the only tool we have developed with a user interface. However, there are many other tools that are able to monitor traffic and to create reports, or in this case of ntopdisk, to dump traffic to disk, that are used by people, sometimes people that don't know that they are using it because it's embedded in systems. This is a good thing from a point of view to discuss and to cover. And finally, Marco Graziano is a friend of us living in the US, and with whom we are working since a few years. We talk about Ntop Defender, that it's a project based on some of our tools that is in essence pushing monitoring and security or defense, if you wish, to the cloud through a system that he has created and called Cometa. And then at the end, we want to have a short discussion in case somebody has questions or wants to comment on what we'll be showing today. Like I said a couple of meetings ago, Ntop is mostly a community. So today, this is, let's say, it's a scheduled event. But in general, many people contact us every day on Discord and on Telegram. This is the URL. So in case you have questions or if you want to interact with us basically every day, you can contact us here, and we'll try to be, alive and responsive. And before starting with with the tools and mprobe, the talk on mprobe, I want to tell you about a couple of ideas that we have in mind. We see that many people contact us for installation support and sometimes for running our tools. So whenever they change something in the installation, they come to us, they say, okay, this is not something that we're able to do ourselves, we need your help, please assist. And this is what we are doing all the time. This is not a problem. Actually, sometimes it's the community itself that is helping other users. However, we have seen that there are some people who would like to have some sort of quality or as an assessment for the installation, because many times people running our tools, use our tools, partially, simply because they know a part of the tools, or simply because they do a simple default installation. So sometimes we have a request of people coming to us and saying, okay, we are happy of the tool, but probably we have not configured the tool at best. We are probably not using the available resources very well. We probably have to improve what we have done. So one of the things we would like to do, and this is something that I would like to discuss at the end of this session, if you want, is some sort of quality. Okay, many companies are doing certification and training. So we, as you know, we do training all the time for free when people come to our physical conferences, or from time to time on the internet we do, training to people that say, I want to know more about this. Okay, let's schedule an event on Discord and people can join. However, training is probably, at least according to our understanding, not enough, because sometimes we train somebody and then the installation is done by somebody else. So at the end of the story, so we see that the software is not working well, simply because the disk is full, the configuration is not perfect. So we see duplicated traffic, we see, let's say, configuration mistakes. What we can do on our side is to add in the software all the possible countermeasures to avoid this type of problems. But if the issues are beyond us, so simply because traffic is not collected at the right place, or if there is some sort of improvement to be done, we would like to offer people some sort of assessment. So a seal, a stamp, where we say, okay, Ntop, the manufacturer of the software, has verified that what you have done is done very well. Okay, it's supposed to work like that, or say, okay, it's working, but probably there is something else you can do, and this is the optimization. I'm not talking about only Ntopng. I don't want to limit the scope to one tool, but we would like to have a broad scope, in essence, to everything we do. So from drivers to mprobe to ntopdisk to influx, for instance, because sometimes the issue is that the installation of the database is suboptimal because it is running on a machine that is not designed for that, or the disk is too small, the system is warping, things like this. So we would like to start offering this sort of service, that is optional, of course, to people who are interested in next quarter. And this will be, something that we do when people want. Okay, so they call us, they say, hey, let's assess our system and meet, from time to time, or whenever the configuration changes. So something to help with the installation, with the optimization. And another thing that we have in mind, but I don't know if it makes sense. That's why I would like to hear from you at the end of this mini conference today, is to create some sort of Ntop managed service providers, something like that, because we see that there are users in our community that are making money, making some revenues thanks to our tools, and we are happy of that. So we would like to see whether it is possible to offer some sort of service relying on these people, a managed service, because I see that people sometimes install the software, look at the top talker in case there is a problem with the bandwidth, and as soon as the problem is solved, they forget the user interface until the next problem comes. So the idea was to think about offering some sort of managed service that Ntop can offer, or other people can offer. This is not something that we have to decide today. But I would like to understand if this is something interesting, because we see that the movement to the cloud, towards the cloud, is a good idea, but moving to the cloud for many people means don't have hardware on premise and put the software somewhere on some remote system, and that's it. So it's not really a service, it's just the first part of a service. We would like to offer a service. So I would like to hear from you again at the end to see what are your views from your point of view, what are the services we should offer, and how we can help people making money with our tools. So this is also the main idea. The second quick news is that we promise in the first conference of the first part of the mini conference to add support for popular tools such as FreeBSD or PNSense. Actually, some people would like pfSense, but pfSense in a way we believe it is becoming let's say a closed product. So it's hard for us to see us maintaining a software on a platform like that. So I wanted to say that mprobe is already working. Okay, and Ntopng, as you know, is working because it's part of OpenSense, for instance. What we have to do, we have to package it properly and to create, one part of the user interface. But one of the first promises we have made, a couple of weeks ago, is coming. So just wait. Next year, early next year, this will be available, and we hope that you will enjoy it in your OpenSense installation. Okay, let's start. The idea today is to talk about mprobe, at least in my session. Okay, what is mprobe? Mprobe, in essence, was initially conceived as a drop-in replacement for a Cisco router. Okay, when I started coding it in 2002, so almost 20 years ago, this was the need. Okay, people wanted to use NetFlow, but the router was not capable, or if enabling NetFlow was not possible because the router was, heavy on CPU or heavy on memory usage. So this was the initial idea. And over the years, mprobe, so the word probe was extended. So not just to capture packets and turn them into flows, but also to do collection. So it means that we collect flows, we transform the flows in some way. So for instance, we had fields, so we make a non-standard flow standard. So working in proxy mode, for instance, or adding extensions that the NetFlow standard, the AppFix standard was not somehow part of the initial design document. And this is the oldest tool that we have developed and that is still available. So this is in essence mprobe. But because of this, so because of 20 years of development, mprobe can do many things. And I bet that most of the people know just a small portion of it. So the idea today is to talk about what mprobe can do and what are the new things that we have introduced this year. So in essence, there are many things that we can do with it. There are people that want to do visibility. So if you are a wireless ISP, so you have many devices like Microtik or Ubiquiti, for instance. There are other people that say, I don't care about flows. I just care about receiving this information and injecting this information into my data lake. For instance, using Kafka, Elasticsearch, syslog, or TCP streaming. So this is actually an interesting use case because many people perceive flow, NetFlow or IPFix or SFlow as an old style, let's say, format. So they are legacy format, if you wish. And also, not many people know that it's possible to extend mprobe with new plugins. So to add new information to it, extending the core. And also that it's possible to collect flows with with custom templates. So for instance, Cisco, Ixia, Palo Alto, or SonicWall. So this is what we are going to talk today. Let's start with the simplest scenario. So in the simplest scenario, you see on the left side some producer of flows. So Microtik, for instance, Cisco, who has created the NetFlow standard, or VMware. VMware is interesting. It's an interesting use case because many people are virtualizing the systems, and some of them come to us and say, hey, we want to install mprobe on the system. But the typical answer is, okay, you can do it, of course, if you want to have very rich flows. But mprobe can also collect flows coming from the VMware infrastructure, so it's VMware itself that is exporting the flows. The main problem here is that those flows are unencrypted because simply, the way the standard was created more than 20 years ago, I think, was exactly that, to send information in clear. But today, this is not possible. So imagine that you have a distributed infrastructure, or even if you're inside one company where the network is safe. So imagine that you want to send those flows to a central location, let's say, for instance, to Ntopng. The nice thing and the nice news is that mprobe can talk with Ntopng with encryption. And this is very nice. And also that we can add the packet inspection to it. Of course, DPI cannot be computed on packets, but if the original flow don't have information about DPI, we can only compute it on IP addresses or on domain names if they are available. So this is the typical way. At the end of each slide, I will put a short command. So in case people want to reproduce it, this is the way to go. So many people are using it with just the first part, but don't forget that we have introduced it in the latest version, the second part, where you can encrypt the data. Of course, you need to use the same encryption key. This is a key that you have to use for mprobe and Ntopng, and the key has to be the same, obviously, on the two sides. Unfortunately, this extension is solely for Ntopng, or if you wish, for 0MQ, because if you use mprobe as a proxy, for example, for sending data to Elastic, so in this case, you have to use HTTPS when sending data to Elastic. You cannot do otherwise. Okay, so this is just a 0MQ extension for using it with Ntopng. Another scenario is to use mprobe to collect proprietary fields. So there are many dialects. When you say flow, doesn't mean too much. Okay, so for instance, there is Fortinet that has V9 flows with custom fields, very custom fields. There is Huawei that has something called NetStream, and there is Juniper that has something called JFlow. So in essence, all of them are IPFix or NetFlow, but with some sort of dialect. Okay, so the problem is that when you send data, for instance, to Elastic or to Kafka, to a broker, many people focus only on the transport, on the statistical part of the story. So for instance, they say we use JSON, but JSON doesn't mean anything because JSON is just a way to format data. But then how do you name a certain field? How do you name the IP address source IP, for instance? This is very important. So this way, thanks to the fact that we can import and we can convert templates, we are able to massage and to make sure that all those flows are sent to the favorite collector in a unique way. And this is very important because here, regardless of the fact that those flows are coming from a Juniper, a Huawei, a Fortinet, or a Sophos, or whatever device, they all look the same. And this is very important because otherwise your statistic, your data lake cannot work because they have to take into account the initial format that can change from model to model. For instance, a Fortinet device can have a version that is different from another Fortinet device. So this is very important to keep in mind. Okay, so this is another use case. Another use case is the following. So to mix the information coming from various type of devices. So sometimes you have Cisco that is not using NetFlow. Okay, Cisco creates also has created also a new format called NetFlow Lite. That, if you want, in a way, is very similar to SFlow. Okay, because instead of sending out flows with NetFlow Lite, we send out sampled packets. Okay, so the idea is the same of SFlow. So suppose that you have an heterogeneous network where you have together, some switches with, for instance, Aruba switches with SFlow, other Cisco switches that speak NetFlow Lite, and other routers that speak NetFlow IPFix. Okay, it can be Cisco, Huawei, or whatever. So this is the typical situation in every network, I believe, where you don't have only one type of products, but you have multiple type of products all in one place. So the idea is that mprobe can do the conversion. Mprobe can collect those flows, like I've said, to send them out in a simple way. Remember that NetFlow Lite is not like NetFlow, so it's a different type of format. So if you want to collect the NetFlow Lite, you have to use --nf Lite, okay? Whereas SFlow and NetFlow are handled by the same tree. Okay, this is not possible because there is no simple way of detecting, NetFlow Lite. So the best is we thought is to use it this way, and also because NetFlow Lite, the way it works, sometimes is very heavy because many flows are exported. So here at the end of this parameter, you put a double column and a number. So that says use so many threads to collect those flows. So in case your performance, is not enough. Another point for which I told you at the very beginning we created mprobe is in essence to transform packet into flows. Okay, so this is the typical scenario. mprobe can do that by looking at the pickup. Okay, looking at PF ring devices. in standard PF-Ring, so the open source version, or in PF-Ring 0 copy, so the fast version. And mprobe can collect those packets and send them to a collector via NetFlow or IPFix. And this is in essence the syntax. So you have to add, the input device, and you have to specify the collector port. If you want, you can also specify the template. Otherwise, mprobe will use a standard template. And here you can specify the flow format. Of course, if you have NetFlow version 5, there is no template needed, because simply version 5 does not have a template. But for V9 and 10, this is the way to go. When you create a template, you specify a template, you specify the information elements that you want to export. So for instance, you specify if you want to export the DNS query or the TLS encryption information. And based on that, mprobe enables or disables plugins that are a way to further dissect the traffic based on the template. This is, the classical mprobe. Over the years, like I've said, people are creating data lakes. They're creating, products where, in essence, they receive a lot of data coming from various places, and they're massaging the data in a way so that everybody can understand it. Probably one of the first, popular product families that did that is a CM, where it's security oriented, but in general, this is an old problem. Okay, so in essence, you have many input sources like packet, IPFix, SFlow, NetFlow Lite, whatever, and you want to send this data not to a NetFlow collector, not to an SFlow collector, but to somebody that has no idea of NetFlow. So a good example can be Elastic, syslog ng, so to print inside the syslog, the flow information. Companies like Fortinet, for instance, are exporting flows also to syslog, so they write, a string to it that is basically the flow, or to send data to a Kafka broker. So mprobe can do all of that. You simply had to add, the option. In this case, -- Kafka. If you want to send data to Elastic, -- Elastic. And note that at the same time, you can export to multiple consumers. So for instance, you can say, this is the single input, okay, we receive out of one input, we want to have many outputs. And the data that is sent out is the same. So it means that it is possible to export this data to every consumer that mprobe supports simultaneously with one instance. This is an important point, I think, because many people are starting to use this paradigm where, in essence, they move off flows towards JSON something that is ingested into their system that they already have. Another example I didn't put on the slide is Splunk, for instance. Inside mprobe, it's also possible to manipulate and to read pickups. Okay, so for instance, there are many products that create pickups. Okay, not just our Ntopdisk that Alfredo will describe later, but there are other products like Solar Capture, for instance, or Endace, or there are products like Corville that are playing with pickups, SolarWinds. There are many companies that are creating pickups. So the idea is the following: so sometimes there are companies that create those pickups, and they want to see those pickups become flows. Okay, and those flows have to be sent somewhere far from the place where they have been captured, or they want to be sent to, let's say, Ntopng, because they want to visualize the information. So this is the typical situation. And in this case, you have to do this. So instead of specifying a device name, here you specify a directory. Okay, so mprobe will read this directory, read the pickup files in order. So the oldest first and the newest later. If the process like Solar Capture is creating the pickup, okay, mprobe waits until the pickup is completed, but it doesn't wait until the end. It does sort of tail. So as soon as the pickup is filled up, so packets are received and the flows are created. And when the flow is created, it is exported to Ntopng or to NetFlow collector, the same as with live traffic. And the timestamp that I put here are the timestamp of the flow. Okay, so written in the pickup. They're not the timestamp of the time when we do it. So it means that you can capture a pickup 2 years ago and export the flow today. And the timestamp is from 2 years ago or from today. You can add other options here. So this is an interesting use case that some people are using simply because they don't know how to visualize the information, but they have pickups coming from source of data like those I mentioned before. Another possibility that not many people know is that with mprobe we distribute also another package called mprobe-dev that contains all the possible files, all the needed information to create a plugin. Actually, it comes with a we call dummy plugin and a makefile. So in essence, you can extend the core of Ntopng and mprobe, and in the case of mprobe through plugin, in the other case of the other tools by other type of components. So in this case, we create a C file, so they call dummy plugin that is doing something. Usually we dissect, some information more in detail by dissecting some protocol more in detail, or we extend the core by exporting information in other formats. For instance, a couple of days ago, we have been contacted by somebody who wants to export data in Avro. Avro is not something that we support inside mprobe. So this is the typical way. So create a plugin so that we don't have to put into mprobe, this Avro support, the Avro libraries, but at the same time to have the ability of exporting all flows in this format. So let's say if you have a custom protocol, if you have a proprietary system and you want to export this data, if you want to dissect new type of protocols, this is the way to go. And again, have a look at the mprobe-dev package that contains this information. Somebody might say, okay, but how fast? So in essence, how efficient is mprobe? Because as you know, we have two families. One is mprobe, the other one is mprobe CentOS that I'm going to talk in a second. So what is the expected performance? So in flow collection or in probe mode, okay? So in flow collection, the flows are created by a third-party device or even by mprobe itself on another device. In probe mode, we transform packets and flows. So let's look at the flow collection first. In this version, we have introduced something called pass-through that I'm going to describe. Without pass-through, so this is the typical case that everybody, most of the people, let's say, use. Flows are coming, they are collected by mprobe, they are put into the flow cache, and the flow cache contains those flows, and those flows are put together. So sometimes there are versions like NetFlow version 5, where flows are unidirectional. So when I'm speaking with B, there are a flow Luca to B and B to Luca, okay? But if mprobe export these flows in version 9, it would be nice to pack those flows together, or sometimes there are versions that are exporting data too often, so we would like to glue together those flows before export. So in essence, mprobe by default is using no pass-through. So it means the flows are coming, they're put into the cache, they're put together, and then they're exported. So this is something about 20,000 flows per second per core, okay? So it's very important. Those numbers are per core, okay? So if you have an 8-core machine, you can start, let's say, multiple mprobe, for instance. This version created something called a pass-through that I'm going to describe soon. So, but in essence, it means that when the flows are collected, they are not put into the cache, but they're simply converted in format, or they're sent out. So an example is the one I shown you before. So imagine that you want to do this, okay? So you want to collect packets or flows and send them to Elastic or to Kafka, let's say. So in this case, if you don't want to modify the flows, so it means whatever you receive is sent out in JSON. This is the typical use case for the pass-through. So in the pass-through, we have a 5x improvement simply because flows are coming. They are either delivered to a remote system or they are transformed and delivered. So this is the important story. As you can see, these numbers are pretty good, especially because they are per core, even though you usually suggest you to use 2 core per mprobe, 1 core for collecting the data, the other core for exporting data. So this is the best configuration. With Packet, you can expect a PF ring without 0 copy, so mprobe on top of standard PF ring or on the modern pickup. You can have more or less 1 gigabit line rate type of performance with standard traffic. Or if you have 0 copy, it's possible to have two type of performance figures. One is 0 copy with plugins or without plugin. So the problem of plugin, for instance, DNS, is that for every single request, there is a flow that is created. And because of that, the flows can be many, because imagine if you're monitoring a DNS server, you will be monitoring also many, let's say 1,000 flows per second due to the DNS. Or for instance, if you are monitoring HTTP traffic, if you're monitoring a web server, even though HTTP is less and less popular, or if you're monitoring email, or if you're monitoring radius calls, these are generating a lot of traffic. So the performance, the typical performance is hard to estimate. But in general, if you have plugins, the performance is half the performance of the same mprobe without plugin enabled. So this is a very important thing. But anyway, the message is that with modern hardware, you can more or less monitor 1 gigabit line rate on standard PCs without too many problems. If you want to go faster than that, so the typical solution is to leverage on hardware. And the typical case is use RSS. RSS is a way to multiplex information towards multiple visual interfaces. How? Simply looking at packets into the card itself is hashing the packets and is putting into the same queue. So in this case, I put 4 queues, the same packet with the same hash. So this means that if you start 4 mprobes, 1 per queue, okay, instead of 1 receiving everything, if you want to multiplex this data, sending everything to the same collector, for instance, to Ntopng, what you have to do is this. So this is the typical syntax that we have in mprobe and with pfring. This is very important to use pfring because without pfring you cannot see the individual queues, but you will see only one queue. So in this case, suppose that the interface we are capturing packet from is ETH1. You can run 4 instances. Okay, don't forget that with mprobe you need 1 license per system, so you can run as many as you want, as long as the hardware, of course, is capable of running, keeping up with the speed. So every instance is fetching packets from 1 queue. So this way you can really multiply the performance. In particular, if you do proper, balancing across the cores, basically it can scale up. It's a simple way of doing that. Not many people are using that, so they say, okay, I have a 10 gigabit interface. I want to receive everything. So they start 1 mprobe instance on top of this interface, and they say, hey, we are dropping 30% of the traffic. But there is a simple solution that is pretty cheap. So you simply enable RSS. You start multiple mprobe instances. In this case, we send data to a NetFlow collector, or in this case, you can send it to Ntopng. Very simple. So this, if you want to go faster. So let's say up to 10 gigabit, this is a good way of scaling up. But if you want to go, we say, super fast, so if you want to say at 40 or 100 gigabit, you probably have to move to mprobe CentOS. mprobe CentOS is, let's say, it's a subset of mprobe, let's put it this way, that is designed to go very fast. So therefore, with CentOS, there is no concept of template, but we have one static template that is very fast, it's very rich, it contains several information elements, but it is not configurable for speed purpose. And also everything is very, very tuned for performance. So this way you can go and do 100 gigabit. If you want to do something above 10 gigabit, you need to do this. Either you have multiple network interfaces. So let's say if you have 40G, 4 times 10, perfect. Otherwise, you need to use RSS. You can use with CentOS RSS combined with multiple interfaces. And the only thing you have to do is you have to put -i and the interface name. And then mprobe CentOS will poll all of them simultaneously and generate flows super fast to the collector. We have done experiments with cars, let's say from Napatech, Accolade, Silicom, with Svenner, with FPGAs, let's say, and it's possible to do 100 gigabit with real traffic with a standard Intel PC. So this is if you have extreme performance. And then I anticipated before the pass-through news that of 9.2. So in essence, with flow pass-through, we don't have to send flows into the cache, but we take the flows as they arrive, we interpret the flows, we send them out. So therefore, the important thing about pass-through is that -t is ignored, simply because the -t is the way to format flows. But in this case, we don't format flows. We use the same flow used by the sender. So we take the flows, we read the flows, we interpret the flows, we match the template, we send the flows out. So let's say to Kafka or to Elastic, to Ntop, without any modification. And because of that, we have been able to go 5 times faster, simply because there are not so many components involved as with the standard mprobe. This is a very important thing that we have done with this version. So you have to use this facility, if you want to go fast, if you have in particular probes that are a little bit rude, that don't send traffic all the time, but that they collect flows in memory for some time, they send all them at the same time in burst. And this is a typical problem for some type of devices. So in pass-through, in essence, you have the same benefit of flow collection, but you don't have the benefit of flow aggregation. So this is very important, but you have speed. And so a typical situation is the one I described here. So in essence, you do net flow collection. You want to export data, even to Ntop or to other type of consumers. Okay, so keep it in mind. With the latest 9.2 version of mprobe, we can support that. And also keep in mind that this facility is good if you have a speed or if you have flow drops, simply because mprobe is not capable of doing flow collection and aggregation inside the cache. Another thing that we have introduced is the flow manipulation. So sometimes when we collect flows, we are unable to configure the router to tell the router, don't send me only these interfaces, but and the router is either yes or no. So send net flow or don't send net flow. And especially there are many routers that have many interfaces, and we are interested only in one of them or in a couple of them. So this is a way of doing that. So in essence, it's possible to add a new file called netflow reforge, so nf reforge, that allows you to specify the list of interfaces that we need to receive, and also to reforge the IP address. Because another problem is that sometimes the traffic is not sent properly, because the router is exporting flows, but there is a NAT in the middle, and the NAT is changing the IP address. So we are not longer able to put together flows and SNMP simply because of that. Fortunately, in SFlow, there is not this problem, because inside NetFlow, the IP address is written inside the flow itself, not with NetFlow. So SFlow is not affected by this, but only NetFlow. That's why NF reforge. So if you create this file, for instance, it says that for this type of exporter, okay, whatever flows is received from this exporter, mprobe resends out the flows as if they were received from this type of exported only for interface 12. Okay, so in this case, it says for flows received by mprobe from .21, we don't reforge the IP, but we export only this type of interfaces. And this is very good because you can reduce the pressure on the collector, because sometimes the collector is receiving too many flows simply because most of them are not relevant, but they have been there simply because the router is exporting everything and not all of them, a part of them. Finally, a nice thing that we have introduced with NDPI, but in this case, you need to have mprobe running on top of packets, so collect packets and transform them into flows, because this is required by the packet inspection. We have created a new information element called L7 protocol risk that is either a bitmap, a number, or a string. So we explicitly write, those risk names, like for instance, a suspicious user agent. Sometimes, for instance, there are user agents where there is a PHP code. Okay, this is a typical way of circumventing security. So this is first example, or this one, weak cipher. So there's a TLS cipher that is very weak. So not just TLS, but also the fact that it's a weak communication, or for instance, the certificate is expired, or there is a mismatch. So all this type of information is computed by mprobe, and when we send out flows, this is the way to go. And we believe that this is the first step towards the direction that we are taking for next year, where we want to export flows with some sort of interpretation, where we write into the flow, the problem associated with them, because like I've said, not too many people want to see, want to have visibility, want to see everything, but they just want to be informed when there is something that is not working as expected. So this is something that we are doing for going that direction. And that's all for mprobe. Now I want to spend a little bit of time telling you what are the options for embedding mprobe, because like I've said, there are many people that need to run mprobe in remote places or in places where there is no NetFlow. So how to do that? So this is a long story. It started the year after I created mprobe in 2002. As you can see, in January 2003, I created this small device based on a Power PC and was a small box running with a dual-core Power PC. It was manufactured by an American company called Cyclades that is no longer existing. So in essence, this was the first attempt to embed, mprobe into a box and give it to people. Say, okay, now you can monitor your remote network. And this is in January 2003. In November, I already done the port of mprobe to Intel, and I created this initial interface for the mbox, where it was possible to configure, a box to say export the flows towards this destination, and somehow do it, at higher speed, simply because this small Power PC device was not designed to be super fast, but you can choose your type of hardware for embedding mprobe, and with the user interface send data out. And from the time we have done several more experiments. This is just a subset of the devices that we have. So at the bottom, you will see a PC Engine AMD-based version. The middle one is Ubiquiti, and the top one on the left is a BeagleBone, and the one on the right is a Raspberry 2. So we have done many experiments, and from time to time we see people coming and say, we need something that allows us to run mprobe on a cheap machine. What can we do? So as of today, what we can offer you are three flavors. Okay, so you can take from the packages, you can take a Raspberry and put mprobe on it. The only problem is that if you want to collect flows, this is a perfect solution because it's very fast. It has a lot of memory. In particular, the latest version have 8 GB of RAM. So even if you have a huge amount of traffic, this is not a problem. And then the collector running inside mprobe, so the Raspberry is fast. It's very fast for this type of problems. The story is a little bit different if you want to collect packets, because the Raspberry has a Ethernet or a Wi-Fi. And I believe not many people need to collect traffic on a Wi-Fi. So the typical use case of having 2 Ethernet ports is not possible here. This unless you put on the USB an external USB adapter. That is possible. I mean, I do that all the time, but it's not nice because you have one box with an external USB that sometimes can detach if people remove it. Let's say it's not professional. It's working fine, but it's not the best. But this is working, okay? We have packages for embedded system on our packages side. Another option that we have explored is to take an existing device. So this is an example. It's Nokia Beacon 6 that is running one Linux flavor called OpenWRT. So we have ported mprobe to it. So if you have a Wi-Fi mesh, let's say based on Nokia, and you have your office or your home with this device, you can put mprobe on it, monitor the traffic, do DPI, and send this data to, let's say, Ntopng, where you can monitor the traffic. Or we have licensed our software to other companies. So this is one example. It's probably not the most popular, but just to give you an idea. So this is one device called cProbe, manufactured by a company called cPacket. And this one, in essence, is a PC with a special form factor, and it's running on top of an Intel card. So this is designed for high speed, actually for 40 gigabit, I believe. And there are various versions. I'm not super familiar with that. But in essence, mprobe, the same mprobe can run on a small device or on a high-end device, the same mprobe. And this is what is available today. You can go to the packages website, you can download the binary, and you're happy. We are in business. The problem is this enough? I'm not sure. In fact, for the future, we would like to have some sort of, let's say, collector edition of Ntopng, so that it allows to do this. I want to put Ntopng in one place. I want to deploy the probe in several places. No need to have a license. So I want to have a license-less probe. And this probe can send to Ntopng the information. Ntopng is my dashboard. This is what I want to do. Oh, and probe sends data to a remote location. That's why we are trying to divide this into 2 families based on the topology. So in software, we already have a virtual machine, Linux, macOS, and OpenSense. I showed today a preview, so this will appear next year. and the hardware. So what can we do for hardware? What are the options available? The first thing that we had in mind to do next year was to create a small device. This is a simple ARM-based device. Actually, it's pretty cheap. It's based on a low-cost ARM. Okay, it can act as a bump in the wire, so the traffic can enter and leave the device like this, or you can put here the management interface on the LAN, and on the one you can plug in your mirror cable and generate flows. This is something we want to do. Of course, it has also Wi-Fi, so you can also monitor Wi-Fi networks, or you can connect to the device through Wi-Fi. This is something we plan to do. We don't have yet plans, firmly set. It's just an idea. That's why I would like to hear from you either today or on Discord or on Telegram, whatever. But I would like to know what is your opinion, if this makes sense. The form factor is very small. Another thing that we have done in the past few years, here there is a blog post, okay, that describes that from 2016. Ubiquiti manufactures a router like this called Edge Router X, that on the website is priced for $60, but you can find it for much less than that. Okay, let's say it's a MIPS-based device, contrary to the other one I showed you before, the yellow one that is an ARM. And through the web interface, you can specify out of the ports here. There is also PoE as a power. That's interesting. There is another version with SFPs. So if you want to put an optical link. So through the web interface, you can specify what ports you want to monitor, and then you put mprobe on it. So it runs, Linux. So you simply have to add one package. Again, go to packages.ntop.org or read this blog post for more information. You can put mprobe on it, and you're done. So it's working. Doesn't have storage like the other one. So in essence, you cannot store flows locally, but for receiving data, so collecting flows or collecting packets is perfect because it's a super cheap solution for that. And to simplify life to our users, we have also created one, called nprobe-conf. So if you install the latest mprobe package or the latest ntop packages, there is also ntopng-conf or mprobe-conf that allows you to configure with a text-based interface. So if you want to put a web interface on these tiny devices, that allows you to configure, let's say, the config file to start mprobe, to stop mprobe, the typical things that you do with that. Simply because we want to do something in this direction. We plan to release something in the next quarter. The idea is that we don't care where you run, our probe, as long as you can monitor your network. You can assess, the traffic that is running on your network. Thank you very much. This has been a long session. I don't know if you have questions or if we move questions to the end. Carlos, do you want to prepare yourself? Hi, Carlos.
Hello.
So, first of all, thanks for being here. So, like I said at the beginning of this discussion, Carlos has done a very good job. I would like him to introduce himself and to present it. Please, Carlos.
Thank you, Luca. Yeah. So hi, folks. My name is Carlos Talbot, and I've been using Ntopng now for a number of years. I'm a senior engineer at Veeam Software, but my hobby is I like to dabble in firewalls and routers and whatnot. So I've used Ntopng on Linux and other operating systems for a number of years, and I think the impetus for developing a solution to run Ntopng on Ubiquiti, and how should I say it diplomatically, has been frustration is a mother of innovation, I guess you could say. So Ubiquiti UDM series does offer DPI, but it is quite limiting, and a lot of incorrect information is displayed on there. So a lot of users that have deployed the solution over the past year have been looking for alternative solutions to provide accurate DPI and getting a sense of what's going on inside their environment. Okay, so that's really the reason why this all started. To give you a little background on the hardware, and it's funny that Luca was talking about some of the embedded devices and the scalability factor. This is what I think was attractive to starting this project. The Unified Dream Machine comes in two models: the base and the Pro. They're both based on a ARM64 processor, quad core, and doing my own testing and also from the specs that Ubiquiti has published, you can see it's a very scalable platform. Just with the base model, using the firewall in place with IPS enabled, because Ubiquiti uses Suricata for the for IDS and IPS. You can almost achieve a gigabit line rate on the base model. With the Pro series, that can go up to 3.5 gigabits. If you turn off the Suricata entirely on the Pro, you can get close to 10 gigabits. The real difference between the two is that the Pro obviously is more scalable. It has twice the amount of memory. It's the same processor speed on both. It's just the additional memory on the Pro is there for other services. As you can see, the base essentially is a UniFi router. It's a security gateway, but it's also the access point. That's why you see that the round dome on top. It's shaped like a cylinder. And then you have the UniFi controller that manages all your devices in your environment, all your Ubiquiti cameras, your wireless access points. But then the Pro builds on that and introduces it's got its own 8 gig switch. It offers not only a gigabit WAN port, but also a 10 gigabit WAN port and 10 gigabit LAN port. So it's much more expandable. And I have both editions. I started out with the base and I went to the Pro, and I've been testing Ntopng on both of them and getting the feedback from users. They're saying that it does work pretty well for both of them. And I'm thinking during this presentation that Luca had about mprobe, potentially introducing that for the UDM, potentially to improve some scalabilities. Okay. So the underlying operating system of the UDM is based on build root. And if you're familiar with that environment, OpenWRT is based on build root as well. It is limiting because there is no package management. I can't use RPM or dpackage to install a pre-built software. Fortunately, though, Ubiquiti had the forethought to include a Docker engine on it. So Podman is running on both the base and the Pro. If you're not familiar with Podman, it's just like Docker, but it's daemonless, so there's less dependencies there. But all the command syntax is the same. And in the demo I'll show you here, you'll see that any Docker command can be used with Podman. So one of the nice things about having that Docker layer in there is now you can install different applications. Both the UDM base and the Pro have the UniFi controller running in a Docker instance, as well as things like the UniFi Protect for camera recording, as well as the UniFi Talk, which is their VoIP solution. So all of that is running on a container. So that's really what got me started. Well, let's look at developing perhaps essentially a Docker for Ntopng. And one thing I noticed, and you go out to Docker Hub, is that there aren't many containers out there for ARM64 like there are for AMD64, right? So, like for example, someone in the chat earlier mentioned, mprobe. There is a container for it. I looked at it though, but there's no ARM equivalent yet, right? So maybe we can change that. One last thing about the difference between the two models is the base has flash memory as well as the Pro for storing persistent data for Docker containers. The nice thing about the Pro, though, it has availability for a 3.5-inch hard drive. It's primarily used for storing video from the cameras, but you can use it for your other Dockers as well, which for example, I use it for my Ntopng. And again, last thing is for the demo, I'll show you here. I have a 1 gigabit synchronous internet line at home, so I'll demo some speed tests and show you the HTOP and how the performance looks for the processes. Okay, installing Ntopng is pretty straightforward. I have a link, and I'll show you here after the presentation to the GitHub page of how to install it. You can see there's some persistent directories in here for like the if you want to do IP address lookup based on geography. We have that ability to configure your unique ID for that, as well as persistent data on all the parameters that you want to specify to Ntopng when it starts up, as well as the Redis database So once you have those directories created, it's just one command to start it up and install the instance. Okay. And then one last thing here too. There's a lot of other development going on with Docker containers for ntopng. One other community member, John, also known as aka Boost Chicken, he's on Discord. He has a bunch of UDM utilities as well as out there, and I'll show you a link on the web page here. He has some utilities, for example, how to start up automatically Docker containers after the router gets rebooted, because Ubiquiti doesn't provide that mechanism, that framework. So he's developed some methods to help with that. He also has containers for Pi-hole, for AdGuard Home, which I use, a couple others as well. So so the advantage of having that Podman instance in there gives flexibility for developers to add more to this firewall solution. Okay. And so with that, I'm going to start the demo here, and maybe I think I don't know if we can answer questions now or wait till I'm done here. Let's go ahead and start. So in case you're wondering too, what's the hardware cost for this? And I'm pulling up the Ubiquiti's EMEA website here, and as you can see, the base is $250 without tax, and then the Pro is $320. There was a sale going on during early in November for Black Friday for I think the Pro series, but it's not that expensive, and giving the raw hardware power of it, I think it's a good platform to leverage for projects like Ntopng. Okay. So this is my GitHub page, and I'll share this link after the presentation. But I go through the documentation of how to install it, create the directories on the server, on the UDM server, and then how to integrate GeoIP, because you do have to register for an address, as I'm sure most of you know, since they don't allow just downloads anymore without registration. And then how to disable Redis if you don't want to use that service, or configure it to point to an external database, and how to do upgrades. And then finally, I mentioned the other user contributor out there, Boost Chicken, otherwise known as John. He has a couple of utilities out there. I mentioned WiredGuard Go for the UDM. I actually wrote a WiredGuard solution as well. It's on my GitHub page, because a lot of users are looking for advanced VPN client integration, and we've asked Ubiquiti for supporting that, but if they can't develop it, maybe the community can. Okay, and you can see NextDNS, Pi-hole, AdGuard, all the other Docker containers that he's developed, and then he has a link to my page here as well. Okay, so with that, let's go ahead and start the container installation. So I'm already logged into my UDM Pro here. Going to go ahead and grab the command to actually do the installation. And you'll see it just automatically pulls the latest image from Docker Hub. And then once it installs, it'll start up. The first thing it'll do when it starts up is I've developed a script in the container to pull the latest GeoIP database. So anytime the Docker instance is restarted, you always have a fresh, up-to-date GeoIP information. Okay, and then once this gets started too, we can actually monitor the logs. If you're familiar with Docker, you can just type, podman or Docker logs to get the status of the running Docker instance. So let's see it's pulling the GeoIP data right now. Okay, and it also starts up the Redis server, which obviously is a dependency for Ntopng. And I think by default I have it listening to the bridge interface, which, like many Linux firewalls, that is what binds the wired LAN with the Wi-Fi LAN. Okay, there we go. Looks like it's come up. Give you a couple of warnings here. That's okay. Let's go ahead and connect to it now. First thing is, obviously, when you first connect to Ntopng, it gives you the default password. It wants you to reset that. So let's go ahead and change that here. And then I should show up at the dashboard here once it's all done. There we go. And then you can see if I jump into flows, I'm already getting flows, and not much traffic is going in right now. You see 94 megabits. I don't know. I have two boys upstairs in their classroom sessions. Hopefully they're not downloading Call of Duty or something right now. But you can see that the process utilization is for the most part. You can see it's occupying some resources there. It's fine though, because I've done some speed tests. Right now I have Suricata running on, as you can see, it's the second busiest process on the server. I've disabled the Ubiquiti's DPI service though, because it's really not necessary here. So let's go ahead and run a speed test. I'm going to pick one of the peers. I'm in the suburbs of Chicago here, but I'm going to pick my provider's closest link, just to show you the pure line rate going from my desktop here to the UDM Pro. Okay. And typically, I've noticed, during busy daytimes with this provider too, this could be typically below 800, 900, but as you can see, my upstream will usually go up to a gig. So this is more a factor of my internet provider, not kind of being busy right now. So, but you can see that all the processors are fairly busy during that time. But I presume potentially if this was tested on an environment that had a multi-gig internet connection, we could see even higher than that. So, but yeah, so that was a quick demonstration of the Ntop NG running on the UDM Pro. Are there any questions?
Carlos, I know that you told us that we have to optimize the CPU, and this is something we have to do. Probably there is something that is not properly working on the UTM. In particular, we have seen that sometimes we spend too much time with Redis. So I put this on our to-do list.
Okay, yeah, because I mean the transmission right now, as you can see, is fairly idle, but it's busy for some reason. I'm not sure why, but it's something.
Yeah, I believe that if you do Redis dash CLI and then you monitor the traffic, you will see that probably this is the case. I see you have some alerts, but they're very few, so nothing really special. So I believe that this is going to be the problem. We are already troubleshooting this issue on Raspberries. So soon I want to see whether we can improve that performance, because we are using too many CPU cycles, as you can see.
Yep.
Awesome, great stuff. Yeah, like you said, putting mprobe is probably another option where you can really have network monitoring, put Ntopng somewhere else. But this is convenient, I think, because everything is on the same host. I'm just wondering about the long-term, creation of RRDs of, if this is a problem. Storage, I mean. What's your opinion on that?
I'm sorry, for the storage, the location of the.
Yeah. So generating a lot of RRDs, time series. Is this going to be a problem because is the disk filling up, or do you have enough space?
Oh, right. Well, that goes back to the the platform of the UDM Pro. It does have a slot for a 3.5-inch hard drive. I happen to have a 4 terabyte drive in there.
Okay.
But
not a problem.
But it's mostly for video recording for all the cameras, right? So I have to share that. So I don't know what kind of capacity requirements are NDIS has, but it could share that potentially, right? So.
Yeah. When we are talking about 10 of megabytes, not gig. Okay. Sounds good. Great.
This is helpful.
Yep. Definitely for me, it was very, very nice. Thank you for being here today. Thank you very much. Okay, Matteo, you are the next in line. Do you want to prepare yourself?
Yes. Can you see me?
Yes. Okay.
All right. I'm Matteo Biscosi, and today I'm going to talk about Ntopng alert endpoints and recipients. First of all, let's do a brief recap. After that, I'll do an interactive guide on how to configure the endpoint and recipient. In the specific case, I'm going to talk about Elasticsearch endpoint with Security Onion and Kibana. And lastly, I'm gonna talk about work in progress use cases with endpoint and recipient. So, what is an endpoint? An endpoint is a system which you send notification whenever an alert occurs. So, when an alert occurs, the matching recipients are identified, and the triggered alert, the specific triggered alert, is queued for delivery. In this way, users can easily receive notifications to their preferred service. And in this way, we can generate a specialized action based on the triggered alert. For example, we have implemented the shell script endpoint. So, whenever you have a specific action, a specific alert, for example, a critical alert, you may execute a specific shell script, and so on. So, let's start with the interactive guide. Ntopng is already up. So this is the main page of the web GUI of Ntopng. And here we go into System. From here we go into Notifications and Endpoints. Let's add a new endpoint. And here you have the entire list of the endpoint. Let's select the Elasticsearch endpoint. And name the endpoint, for example, miniconf.test. And here, just like it's written here, you have to add the link, the URL for Elasticsearch. In my case, it's this one. And the port for Elasticsearch. The standard port is the 9200. So let's click on Add. And after that, let's go into Notifications and Recipients. Create a new recipient. Select the previously created endpoint. And here, optionally, insert an index. So, like I said before, I'm gonna show an example with Security Onion because Ntopng now support the alert with Security Onion. So if we insert so minus Ntopng, we receive a Security Onion alert. After that, select the minimum severity for the alert and the category of the alert. So if you want to receive only system or security alerts, you can check the endpoint if it's working, and after that you can add this recipient to all pulls if you click here, or after that you have to go here into pulls and add manually to the selected pulls, for example the host pulls, the specified the specified endpoint and recipient. So another thing is that for a single endpoint we can have multiple recipients. Why should you use that? The reason is simple, because maybe you want to have, just like I've shown, the same Elasticsearch URL, but you want to have different notifications there. For example, just the critical with a specific index, and the debug alerts with another index, and so on. So after doing that, let's go into Kibana. Kibana will show the alert from Elasticsearch. And here we can see the alert from Ntopng. So we have the alert with the destination IP, port, and so on. Let's see the log output ratio alerts. Let's wait a few seconds. Alright, so here you see the level 7 protocols, the source IPs, destination IPs, and so on. Here in the specific you can see the JSON from Ntopng, and so on. So now we are working on developing Ntopng with fail to ban or the system firewall. In this way, whenever an attack occurs, you can block the attacker calling fail to ban or just sending a specific notification to the firewall, and so on. In conclusions, so endpoints are really useful and easy to configure tools specialized in receiving alerts in a flexible way and performing specific actions based on the triggered alert. And like we have seen, they can be used to integrate Ntopng with external system like fail to ban, or just use Ntopng as a system that delivers alerts to external platform like Security Onion, and so on. I'm done here.
Thank you, Matteo. There is one question on the chat asking how can we have recipients for the internal built-in recipient SQLite. You want to add some words on that? He basically said that this is used internally by the user interface, and that recipients can be added to external recipients as you have shown, for instance, for Elastic, for Telegram, Discord, but not for that one that is used by the user interface.
Yes, and basically they are already configured with SQLite or the others. I'll share my screen in a second. As you can see here, you already have an SQLite based endpoint, and you receive all the notifications and alert in this, for example, in this screen.
Okay, very good. Thank you, Matteo. Alfredo, please.
Yes, can you see me? Can you hear me?
Yes, yes, very good.
Okay, great. I guess you can see my screen.
Sure.
Okay, so today I want to talk about Ntopdisk again. I mean, during the first day of this conference, we have already seen what are the new features introduced in Ntopdisk 3.6. But that was a quick overview. Today I want to show you how to use that features and other features that are in Ntopdisk in order to build a 1 gigabit traffic recorder. How to get the most out of Ntopdisk. So a quick introduction. So when we have to troubleshoot a network issue, or we have to troubleshoot a security incident, for instance, we want to go back in time and drill down the traffic up to the packet level to provide the evidence of the incident. In this case, we need to record raw packets using a sliding window, let's say, in order to be able to actually go back in time and select the traffic that we want that flew in our network. In order to do this, we need to record the traffic, add the new traffic to a storage, and delete the old traffic in order to make room for the new traffic. This is what I call a sliding window. And the size of this sliding window is actually the data retention, defines the data retention. So how much traffic we are able to keep in our storage. Ntopdisk implements this. So Ntopdisk is able to continuously dump traffic to disk at line rate, full rate, with no packet loss up to 100 gigabits. But this requires a proper configuration, as we will see today. The raw packets are dumped to disk using the standard pickup file format, which is the pickup format, the file format that you usually use in our tool like Ntopng, but also other tools like Wireshark or TCP dump. So you're able to process the data with any tool. The packets are not just stored to disk in pickup files, but Ntopdisk also is able to index the data on the fly, organize the data in a timeline, so that you can at some point search for a specific traffic by specifying a time interval. So I want to get the traffic from last night from 10 to 11 in the evening, and a specific filter, BPF filter. So I want to get the traffic matching a specific host, port, and application, for instance, we will see later today. In order to build a recorder able to record 100 gigabit line rate, we have to consider a few elements. First of all, we have to choose the right capture adapter. First of all, because we need an adapter that delivers enough performance to keep up with the throughput, with the traffic throughput. We also have to pay attention to the system configuration, the hardware configuration, so CPU, memory, and other configurations. And we also need to pay attention to the storage configuration, both for the performance, so in order to be able to keep up with the traffic throughput, and for the storage size that defines our data retention. So let's start with the capture adapters. Ntopdisk is able to capture traffic from many adapters because Ntopdisk is using PF-Ring as packet capture framework, and PF-Ring supports almost all the adapters on the market. So we are able to capture traffic from commodity adapters like Intel-based or FPGA adapters, which are more expensive, but they are specialized adapters for the packet capture, and they are faster usually than standard adapters. If you're using a commodity adapter, if it's Intel-based, we have our zero-copy drivers that deliver high performance, so you're able to capture traffic at 10 gigabit or multi-10 gigabit line rate with no packet loss. We also have accelerated drivers for Intel adapters up to 100 gigabit. But in order to capture 100 gigabit using an Intel adapter, you have to use RSS, which is what we have seen before with Luca during the mprobe presentation, is the ability to spread the load, to spread the traffic across multiple queues, multiple data streams. But with Ntopdisk, we usually want to avoid using RSS, especially if we need to preserve the packet order, because if we split the traffic into multiple data streams, we lose the packet order. With FPGA adapters, this is usually not really a problem, because even if we spread we split the traffic across multiple data streams, those adapters usually are able to compute at another timestamp with the nanosecond precision and not the timestamp to the packet, so we are able to reorder the packets later on. So in essence, if we want to build a recorder up to 10 gigabit or multi-10 gigabit, we can use Intel adapters using our zero-copy drivers. If we have to record up to 1-2 gigabit, we can even use any standard adapter without specialized drivers, just standard PF ring. If you have to process 100 gigabit, you have to use an FPGA adapter. Those adapters also support usually the pickup chunk mode, which is a fast way for moving packets from the adapter to the memory and to the disk. So you need those adapters in order to dump 100 gigabit per second to disk. A couple of slides for the configuration of the adapter. So if we have a standard Intel interface, we want to use our accelerated drivers, we can use this script pfring config in order to set up the adapter. So you just need to run pfring config with config driver, IXGB in this case, which is the interface model, let's say, and RS queues set to 1, so no RSS, just a single data stream. If you have an FPGA adapter, usually there is something extra to configure. For instance, if you have Napatech, you have to change the configuration file of the adapter, specifying that you want to use the pickup chunk mode, and this is an example. This is usually what you need to add to the file. And then you start the Napatech service and you get the adapter working. Then there are other special configurations. For instance, if you want to merge the traffic from multiple ports and create a single data stream, or then split across multiple data streams. And this is an example for doing that. Okay, what about the system configuration? So if we have Axion system, a 3 GHz CPU, Ntopdisk is able to handle about around 50 gigabits per second using a single capture thread, so a single core for capturing traffic for moving packets from the adapter to memory. And then we need additional cores for indexing the traffic, because we have seen that Ntopdisk is able to capture and index the data on the fly. So we need 3-4 cores to handle 50 gigabits per second. And then one more core for dumping the traffic to disk. So with 6 cores, we can handle 50 gigabits per second. If we need to handle 100 gigabit, we need to double the number of cores, so 12 cores. As of the memory, we just need to make sure that we populate all the memory channels supported by the CPU. Axion scalable CPU, like Axion Gold, supports 6 memory channels. So if we add 6 memory sticks of 1 gigabyte each, that's enough to handle even 100 gigabit traffic. Now let's take a look at the storage performance. So at 10 gigabit, in order to keep up with the traffic rate, we need a write controller with at least 8, 6, depending on the disk speed, standard hard disks, or we can use SSDs. In that case, we need less disks, like 3-4 disks. But then we will see later that we also need to pay attention to the data retention, so to the storage size. If you are processing 100 gigabit, hard disks, standard hard disks or SSDs are not enough usually. At least a RAID controller or those that we have seen are able to dump up to, let's say, 40 gigabits per second. So they're not enough for 100 gigabits. So we have to use NVMe disks. NVMe disks are special SSDs which are directly connected to the PCI bus, and a single disk is able to handle even 10 gigabits per second or more. And we need at least 8 of them to handle 100 gigabits per second. So if we have to record 100 gigabit, we need NVMe disks. And they don't require RAID controller because they are directly attached to the PCI, and we will see later that Ntopdisk is able to write directly in parallel to all those disks. So we don't need a RAID controller for doing that. And we 8 disks, for instance, we have seen that we're able to write 140 gigabit per second, at least with the disks that we used in our boxes. So NVMe disks are directly connected to the PCI. If you buy a standard server, like a Dell server, you usually get with NVMe disks, you usually get systems like dual CPU with 10 NVMe slots, 8 or 10, depending on the server. And you have to pay attention to the what we call NUM affinity. So where those disks are connected, which CPU those disks are connected, because PCI lanes are connected directly to a CPU. So you have to make sure that the NVMe disks that we're using are directly connected to the CPU where Ntopdisk is running. And as Ntopdisk, as I said, is able to write in parallel to all the disks. This is a sample configuration. So in this case, this is a configuration file for Ntopdisk, what you usually find under etc ntopdisk something.conf. In this case, we are capturing from an APATEC interface, actually an APATEC stream. We configure the maximum file length, so we are producing pickup files up with the maximum size of 2 gigabytes. This is a configuration of the in-memory buffer. There is the CPU affinity for the reader thread, for the capture thread. We are enabling the timeline for organizing the pickup files in order to accelerate the traffic extractions in a specific time interval. We are configuring the index, the CPU affinity for the threads which are indexing packets on the fly. And here we have the storage configuration. So in this case, we are specifying the dump directory multiple times. And on each line, we have a different volume. Each of them is the mount point of an NVMe disk. So in this case, by specifying multiple times the dump directory, we are telling Ntopdisk to write in parallel to all those disks using round-robin fashion. And then for each of the disks, we specify the core affinity, because there is one thread allocated by Ntopdisk for each disk. And we can reuse the same core multiple times because there is some IO weight here, so we can, the thread is idle most of the time, so we can reuse the same core multiple times. And then we specify the disk limit, so the maximum amount of disk space that we want to use. This was about performance. Now let's see about the sizing. At 10 gigabit, we have 1.2 gigabytes per second to dump to disk, which is 100 terabytes per day, which is already a lot of data. When we move to 100 gigabit, we have 1 petabyte per day, which is really a lot of data. And we have seen that we have to use NVMe disks to keep up with the speed. But on the other hand, those disks, as I said, are usually available in a limited number. So in a standard server, we have 8, 10 disks. With 8, for instance, just to show you an example, with 8 disks, of 2 terabytes each, we can store, let's say, 20 minutes if we have 100 gigabit line rate traffic. And I also say that Ntopdisk allocates threads and resources for each of them, so we cannot use really many disks, even if we have them in our server. And of course, they are more expensive than standard hard disks. So in order to overcome this limitation, we can use a solution. We can combine a storage based on NVMe disks with a storage based on hard disks, where we can have much more space. And we can combine the two using a storage hierarchy, let's say. So we can dump to the fast cache during busy hours. So we use the NVMe disks as main storage, and then we move the data off peak from the main storage to the hard disk based storage. And we can do this as soon as we have time, as soon as we have enough bandwidth on the throughput on the I/O, or during overnight, for instance. So this we can see here how Ntopdisk is writing to the NVMe cache and then moving data to the storage overnight. Okay, this is the configuration for enabling this configuration. This is the same configuration file that we have seen before, but we added at the end one more line that specifies the mount point of the storage, the hard disk based storage, let's say. So Ntopdisk with this configuration is dumping to the NVMe disks, and then off peak is writing data to the storage, which has been configured in the active storage, active directory setting. Ntopdisk provides even more flexibility, so you can even execute custom actions. So instead of letting Ntopdisk moving the pickup files from the main storage to the secondary storage, you can write your logic in a shell script, for instance. In fact, Ntopdisk, every time Ntopdisk writes a pickup file to disk, is able to call a command which has been configured in the configuration file using the exec command setting, and the file name of the file which has been dumped to disk is provided as parameter to this command. So in this case, we have a simple bash script which is printing the pickup file name. So here you can add your logic for moving the pickup file, for instance, or for doing some processing, some analysis, for instance. Okay, so now we have seen what is this hybrid solution for increasing the disk space, the storage space. But probably this is not enough, because at some point we hit some limit. So how to increase the data retention without touching without adding more disks? We have a few options. First of all, two families of options, let's say. So we can reduce the data, of course, the input data, or we can compress the data. Reducing the data means filtering the data or slicing the packets. So cutting the packets up to the header, for instance. Or we can compress the data, so we can compress the pickup files on disk. When we enable packet slicing in Ntopdisk, we're able to specify up to which header we want to dump the packets. So we can say to this case, cut the packet at the IP header or at the TCP UDP header, because sometimes we are not interested in the payload, but we want just to provide evidence of the packets as transactions, let's say. So storing IP and TCP or UDP header is enough. And this saves a lot of space, because average internet packets are 500 bytes or more. And instead, just the packet headers are less than 60 bytes. So we save a lot of space on disk the headers are enough for us. Or we can compress the pickup files. As we said last time, internet traffic is almost compressed, is already compressed. If we think to the images like JPEG or music, MP3 or video, MP4, MPEG-4, they are already compressed or are to compress like encrypted traffic. Instead, if you have LAN traffic, local traffic in our private network, probably there is a lot of traffic in clear or uncompressed, so we're able to compress it very well. So in case of internet traffic, we don't save much, you save 5–10%. Instead, in case of LAN traffic, you can save more than 50%. Or there are some applications like in frequency trading where the traffic can be compressed really, really well. In order to enable the compression, you have to add the pick-up compression option to Ntopdisk and to allocate a few threads for the compression. So in this case, we are allocating 4 threads specifying the CPU cores. So this adds some overhead, and it's usually not recommended to enable it if you don't really need it. Another option, as we said, is the filtering, packet filtering. The problem with filtering is that you usually don't know in advance what is the interesting traffic, at least not IP or port based, because you don't know if the traffic for a specific IP will be interesting or not. But you probably can do something smarter. You can filter traffic based on the application product. Because if you look at internet traffic, for instance, most of the traffic is multimedia traffic or encrypted traffic, and you cannot do much with that traffic, or it's not really interesting for you. What is interesting is usually a small portion of the traffic, which is all the other applications. So in Ntopdisk, you can discard or shunt this kind of traffic. For instance, Netflix, YouTube. With shunt, I mean dumping just the first packets of a communication. So for instance, you want to see that there is some, I don't know, Netflix session, but it's useless to dump all the movie. You just want to dump maybe the first 10 packets. This is what we call shunt. So you can specify that you want to dump the first packets of a communication. You can configure the layer 7 filtering in Ntopdisk using the L7 filter conf option, where you specify a file with the configuration of the filter, containing actually the rules of the filter. And this is an example of configuration file. The format of this file is the format accepted by pfring FT. So if you look at the pfring FT user guide, you get this example. And you can specify here the application names supported by NDPI, because NDPI is used for the layer 7 detection. So if you look at this example, we are saying that we want to, we want to dump the traffic by default. So we say default forward. We want to filter out YouTube and Netflix traffic, and we want to dump just the first 10 packets of TLS sessions. Okay, let's talk about the traffic extraction. So, okay, we have seen how to dump the traffic, how to optimize the storage to improve the data retention. At some point, we have to extract the traffic. We usually have, especially at 100 gigabit, usually have a lot of data, and searching for some traffic requires a full scan of really terabytes or petabytes of data. Or especially if you want to extract traffic matching a selected application, we cannot do that using BPF. So running TCP dump on all our pickup files doesn't work. So Ntopdisk is able to index the data on the fly in order to accelerate packet extraction. And as we have seen, ntopdisk organize the data in a timeline, so that we can search for specific traffic specifying a time interval. So we can search based on time and specifying BPF filter. So we can search based on IP, port, protocol, and we will see also the application. In fact, ntopdisk is able to also to index the traffic based on the layer 7 application protocol. And we can run instructions, for instance. This is an example using our mpcap extract tool, but we also have other ways for extracting traffic, like we have C APIs, we have REST APIs, we have a lot of ways, even from Ntopng. In this case, we are running this tool for extracting traffic from this storage, and we are creating as output a pickup file, and we want to get the traffic matching this time interval, so we specify the begin and the end time, and specify the BPF protocol. And as you can see here, this is an extended BPF. In fact, we are specifying the host and the layer 7 protocol. So we are trying to retrieve traffic for this host, matching the application Facebook. Of course, we have to enable layer 7 indexing in ntopdisk in order to be able to use the filters based on the application. You can do that adding the extended index equal to in the ntopdisk configuration file. Okay, let's see also traffic visibility. So we are dumping traffic to disk, but at some point we want to have visibility on the traffic. We want to see what's going on, what we are recording, and run extractions based on that. So ntopdisk can be integrated with Ntopng. This way you can drill down from the Ntopng user interface from the historical charts, for instance, as we can see in this picture. Here we are in the interface page in the historical chart, and we are selecting a time interval, and we have here a button to download the pickup file, the pickup data matching this time interval. And we can also add a BPF filter to restrict our search. We can do this also from the host page, so we can download the traffic matching a specific host, and again, we can fine-tune this extraction, adding more criteria using a BPF filter. Or if we can even go inside the alerts page, if we have, for instance, a flow alert, so a flow that triggered an alert, and we want to download the packets for this flow, so the traffic that triggered this alert. So we can do this clicking on the drill down icon here, where we have this download button. In order to do this, of course, we have to enable the ntopdisk and Ntopng integration. Up to one gigabit per second, it's really easy because we have just to go. Of course, we have to install both Ntopng and ntopdisk in our box. Then we go in Ntopng in the interface page, in the traffic recording icon, and we enable the continuous traffic recording. This is possible because in this case, Ntopng is spawning a new ntopdisk instance, is creating a new ntopdisk instance on the fly, and both Ntopng and ntopdisk are capturing packets from the network interface. Ntopdisk is dumping pickup files to disk, and whenever you click on a download button on the historical chart, for instance, or when drilling down from an alert, Ntopng is running a traffic instruction. So Ntopng is reading pickup files from disk and providing you the result of the extraction. Instead, if we have more than 1 gigabit per second, we usually need accelerated drivers like zero copy drivers or Intel adapters or FPGA adapters. And in this case, we cannot run both ntopdisk and Ntopng on the same network adapter because they usually provide exclusive access to the adapter. In this case, we can configure ntopdisk to capture the traffic from the adapter, and ntopdisk can dump the pickup files to disk, and at the same time compute the flow metadata, so similar to NetFlow, and send this information to Ntopng. This is similar to what mprobe or mprobe center do. So they actually, in this case, ntopdisk actually acts as a sensor, because it includes the support for pfring ft, which is flow table, which is a library that you can use to write a sensor, a NetFlow probe. So in this way, Ntopng has visibility on the traffic through ntopdisk. And you can, again, visualize the traffic, run instructions, and do whatever you do also in a similar way of the other configuration, where you enable ntopdisk directly in Ntopng. In order to enable this, you have to add to the ntopdisk configuration file the ZRMQ option, where you specify what is the endpoint where Ntopng is listening for flow data. And you specify that you want to export flows. And you add the ZRMQ endpoint to Ntopng. Okay, I had a few bonus slides, but we're running out of time, so I think it's time for Marco to talk. Marco Graziano.
Hi, Alfredo.
Hi, Marco. How are you?
Great presentation. I have a quick question regarding your work here regarding the compression.
Yes.
And when it's enabled, is there any impact on performance in terms of how much you can capture and store?
Yes. In fact, as I said, it's usually not recommended to enable it because it adds a lot of overhead. And if you have LAN traffic, 10 gigabit, maybe it makes sense to enable it because you save a lot of data. You save more than 50% if you have traffic which is almost unclear. But if you're running a 100 gigabit recorder, especially for internet traffic, it doesn't make sense to enable it because it requires really a lot of CPU cores, and probably you cannot keep up with the traffic according to the traffic, and you will not save a lot of space.
I understand. No, it was interesting in perspective of possibly uploading pickup files to the cloud. It would be an interesting feature to send them compressed.
If you're running an high frequency trading, for instance, service, in that case you compress a lot, and it makes sense in that case. But usually, if you have internet traffic, you don't save a lot. So.
All right. Okay. Thank you.
Thank you.
Yeah, I'm requesting control here.
Let's stop the screen sharing. Yeah.
Can you see my screen?
Yes. Good.
Okay, so we are on. Yeah, thanks, Luca. Thanks, guys, for inviting me to your web conference this year. It's been a pleasure working with you all this time and this year. So my name is Marco Graziano. I am currently, founder and CEO of a company called Final Foods here in the Bay Area. It's a company we just started this quarter. And Final Foods, it's an alternative protein technology company. So it's a biotech technology company. We create equipment and make equipment and knowledge to farm food proteins from cells and not animals. So we are working on a blueprint of a cloud monitored process and microplant to make food protein from recombinant yeast. That is, yeast cells have been bioengineered to produce food proteins such as whey, for instance, and make wonderful vegan cheese from these proteins. So we're starting in 2021. We are offering lab courses from biohacker space in Santa Clara, BioCurious, and these classes are going to be online. I will show how to use a bioreactor and how to do the technology to make these proteins. However, my background and my career has been in the computer industry, like many of you guys. So I am a technologist and a software engineer as training. I started in the 80s at Ubiquiti Research in Pisa, where I was working on things like, the Acorn computers and ARM. At the time, Ubiquiti was actually, these were divisions of Ubiquiti. I worked at operating system and Linux and Unix at the time, sorry, for the Ubiquiti mini computers and some other projects, including porting a Mac operating system from Carnegie Mellon University to our machines. And I moved to the United States in '89. I worked at the Ubiquiti Advanced Technology Center in Cupertino on Unix, and networking was my topic, and TCP/IP at the time was just becoming popular. Well, to make it short, I had a long career here in the computer industry. I worked for Sun Microsystems, VLSI technology on chips for the Newton, Apple Newton, and micro COS port on ARM. I started a company in '95 for information appliances, company that created the set-top boxes and web-enabled phones and licensed technology around the world. Another company in 2000, a web-based and service for home monitoring and home security, including video. We created a home gateway based on small ARM microcontrollers and Linux at the time. That also was licensed to a number of companies around the world. I did a stint on video and video analysis with M7 real-time encoders and DSP hardware. And in the past 10 years, between, till last year, I've been working on IoT, specifically cloud and IoT products for energy efficiency. So, but I'm here today to talk about a project I've done with a friend of mine, Jamie Smith, another, it's a great engineer living in England. I've done several projects with him. And this is the Ntop Defender, which is a network appliance for cyber security and to basically safeguard, customer networks and provide some basic service and protection for home networks or small business. So we call it managed network security, and it's composed by two parts. So one is the consumer premise equipment, so the Ntop Defender, the network appliance running Ntop software and some other software to connect to the cloud. But these devices, don't have local interface. They are remotely managed by a service in the cloud. And then this is, like I said, for small networks, typically for retailers or home office and small businesses, and provides a basic level of privacy protection from cyber threats, help to troubleshoot security issues, and more importantly, set access policies for devices and users in the network, get a notification about suspicious activities on the network, and so on. So the Ntop Defender is the hardware and the consumer premise equipment to provide the service. It is based on an OEM product from a Taiwanese manufacturer. The main is a single board computer based on the Marvell dual CPU ARM core at 1.2 gigahertz. And it has several features, this CPU, that are interesting for our application. So it can have a secure boot from a one-time programmable memory, which can be completely locked. It has two Ethernet interfaces and a switch, a hardware switch to connect the two. I'm sorry, 1 GB of RAM and 4 GB of eMMC that, I prefer, to SD cards and other options. Very small power consumption, is a small metal enclosure, 12 by 8 centimeters. And we are running, OpenWRT on this hardware, and a software, like I said, NFW from Ntop, which is probably I can characterize like a small and kind of reduced version of Ntopng with no need for storage and very core software. So the cloud and the service architecture, this is the very rough diagram of it. So you can imagine like to have on the left the customer network, the premises with a gateway, an edge gateway, a router, edge gateway, the Ntop Defender in line with a Wi-Fi access point to provide access to local devices, and this is the typical inline configuration of a network capture and monitor device. So and on the cloud side, on the right, this is the cloud infrastructure, is based on two major components. One is a message broker that I wrote a few years ago to work on IoT and high performance and highly scalable message broker that is for bidirectional access to remote devices on the internet. So there is an agent running on the Ntop Defender that connects to the Cometa message broker and establish a permanent two-way and encrypted on TLS communication channel with the message broker. The message broker itself is a standalone server in the cloud and offers APIs for applications to interact with remote devices. And the infrastructure for a cloud application that I have implemented is on Google Cloud. Specifically, it uses Google Cloud Firestore as a database, and the App Engine and some cloud functions. So this is a device management application, and all devices that are connected to the Cometa message broker are then visible and managed by the application on Google Cloud. And this is a very scalable architecture. I mean, the Cometa message broker on only one server can manage 1 million devices with a round trip average over TLS of 50 to 200 milliseconds. And obviously, Google Cloud, it's basically a highly scalable and performing cloud infrastructure. So, well, this is a quick, sketch about the Cometa message broker. So it is for devices that are inside a NAT or private networks. It initiates the connection. The agent initiates the connection to the server, establishes this connection permanently. It will reconnect in case of drop or any other reason the connection is lost, and is used by applications on the left to send over HTTP or WebSockets commands like remote procedure calls that the agent will execute on the target device. And in our case, the agent is interfacing with NFW using the local HTTP server, and all the functions of NFW are now available remotely to the applications on Google Cloud. So maybe it's time for a quick demo. So I don't know if you see the browser with the demo or not. I don't see the red around it.
No, we see the slides, Marco.
Okay, let me switch. So maybe the best is to move inside here. So, okay, I just logged in. I bypassed the log step at the moment. So this is the main. This is the list of all the appliances that at the moment are managed by the application. So these are all Ntop Defenders or development devices. Most of them actually at the moment. So the two on the bottom are two Ntop Defenders that are currently connected. Their ID is an active link, and one is in England at Jamie's home, and one is in my house in Palo Alto. And as you can see, we have immediate notion of connecting what devices are connected or not. So there is a presence capability in the Cometa broker that in real time will switch connected to disconnected. So I am now directly talking to the Ntop Defender in my network. So these devices do not have any local interface. So they are fully managed through this cloud application, and this is the interface. Here, the idea being that as a managed service, the service provider is taking over, responsibility and with expertise to set up these appliances for their customers, so that the end user and the customer is receiving emails and alerts regarding the network, but it doesn't have to set up specific policies or user groups or any filters that the NFW is supporting on the Defender. So again, the Defender is in line, is monitoring and policing all the traffic to the internal network, and this is the interface. This is the appliance in my home. This is a summary of the network traffic and load. So one of the very important features of the Ntop Defender is to filter and trap all DNS requests of all devices that are connected in the network. In this case, sending all DNS requests to a secure DNS like Quad 9 that will filter out domain names that are suspicious. So, and this will be done automatically. Another feature is the ability to shape traffic to the internet, and in a way that we'll see in a moment. It's also a very interesting feature of a captive portal. One of the feature security of the Ntop Defender is in fact to control users, and we can enable a captive portal for all users to log into the Ntop Defender before they can access the internet. So users of the device are defined by the administrator. So users need to be created and added to the system from the interface. And these are online users of my network at the moment. And there is a summary of the traffic of the user and with all his or her devices. So there, in my case, for instance, there have been 374 flows that actually been stopped. I can see this here. And these are probably advertisement, but we'll see later how we can figure this out. Advertisement or malware or suspicious websites filtered either by the DNS or by the blacklist, the IP address blacklists that are on the Ntop Defender. And once we can drill down to a specific user, so these are the devices in the network that are associated with me on this network. And these are the policies that I can have on all the devices of the user. And so here at the moment, I'm dropping and stopping flows from advertisement or trackers and miners. access to the internet can be limited to certain days of the week and time of the day. And here is the very interesting features that you guys are familiar with for that also in other Ntop products, which is filtering or shaping or dropping completely flows that are that belong to specific categories, and there are a number of categories available, and this in my case I'm all applying a default policy for all categories, and here I have the traffic for each category that comes from the Ntop Defender, and I can change, and again the service provider in this case will define after understanding the usage needs and the security needs of the customer, will help the customer defining what to shape or to drop. It is presumable that in a retail store, for instance, there might be a network for customers or a network for employees, and they may have different policies in terms of what kind of traffic is desirable the users of the network will have access to. And there is also the other lower level filtering at protocol level, and these are the layer 7 protocols that you guys are familiar with and use Ntop products with the NDPI and so on. When devices connect to the network, either through Ethernet or the Wi-Fi or whatever method, the Ntop Defender will understand a new device is connected, and it will belong to a list of unassigned devices. So the idea being that an assigned device is then assigned to a user, and type is specified. This is most likely a laptop, and the device is immediately added to the list of devices here. And these are devices per users. And the association can be changed, or device can be removed from the associated devices, and so that it can be then reassigned to another user. Again, here the idea being that the network, the service provider provides this kind of a setup for their customers. This is a list of events that have been captured by the Ntop Defender, and the specific one, and sent to the cloud. And these are this is specific to all the users. And in terms of websites visited, and this can be then separated among users, and these are the type of website and the number of visits to that website. And there is a summary statistics of network traffic for specific users of the device. Again, all of this is coming to the browser from the Google Cloud application. The Google Cloud application is issuing requests to remote devices through the Cometa message broker. The Cometa agent on the Ntop Defender is receiving these requests and issuing local commands to the NFW through the local HTTP server, getting results, packaging back, and sending back to the requester, again back through the Cometa message broker. The requester in this case is the Google app application that I wrote, and the browser here, through a JavaScript interface, getting these responses and presenting them over here. Again, I want to stress the fact that this is an interface that is used to manage multiple devices in wherever they are on the internet. So you can see the connecting speed is as fast as it can be, probably, and it's almost unnoticeable that one device is here in California, another device is in England, and is centralized management. So I want to just quickly conclude this presentation. I think the really the demo was the main subject that I wanted to present. And if there is any questions or would like to know more details, please let me know, let Luca know. And in any case, guys, was great talking to you, and great work. Luca, Simone, Alfredo, all you guys in Pisa, you guys rock. And I can't wait that we'll be able to travel again.
Marco, thank you very much. But I see a lot of potential in this system, and I would like to ask you, what are your plans for, for selling it, for introducing it? What do you think is going to happen next year with this product?
Yeah. So just wrap up the integration just in the last few days. The hardware is available. We can acquire hardware appliances from the manufacturer. The software is basically completed on the device, and it's under testing. And the cloud, it needs to wrap up some features like automatic email and similar. The plan is to partner with managed service providers. Companies are interested in marketing this technology and partnering with us, with Ntop, to make this into a commercial offering. And we know we are based here in the Bay Area, but we work with companies all over the world, but again, until now, it's been mostly focused on the technical development.
Yeah, very good, but I see it very advanced. So hopefully next year we can see, the product out. Good. Thank you for being with us for such a long time, Marco. Thank you.
Thank you, Luca. Bye.
So this was the last presentation. I don't know, guys, if you have questions you want to ask, or if they're about support, I prefer to move them to Discord. I'm just asking questions about what we have seen today. If there are feedback on the idea of having some sort of quality on the product, if you're happy with it. It has been a long session today, mostly because of me being late. Okay, good. So I just wanted to thank everybody. This year we couldn't have a physical conference, so we have done this over the internet. We want to sync up from time to time. I wish all the best to all of you. Enjoy your Christmas break and the holiday season. And hopefully, next year, like Marco said, this virus will allow us to travel again and to meet people in person. So thank you very much to everybody. We'll put the video on YouTube and our website as usual. Thank you.
Thank you, everyone. Bye-bye.
Thank you. Merry Christmas.
Merry
Bye-bye.
Christmas.